For this second part of part 1 for Project 8, what I'm going to do is do a calculation for Poisson, that distribution, and let's talk a little bit first about what that distribution does. It results from a Poisson experiment, but that experiment is got some certain properties. It has outcomes classified as either a success or fail. The average number of successes is mu, and it occurs in a region that's specified, and it is also known. The probability that a success will occur is proportional to the size of the region or the area under the curve. The probability that a success will occur in an extremely small region is virtually just 0. It's going to be a very, very small number. Now, the specified region could be length, area, volume, period of time, but we're just going to be looking at the distribution on a graph. The formula for this is going to be e to the negative mu times mu to the x, all that divided by x factorial. And we can calculate the probability of something happening by hand, but GeoGebra has this nice little feature here where you can change the distribution to the one that you need, and then you can also change the left and right limits here. So here's the mu, and my problem set given is a life insurance salesman sells on the average 3 life insurance policies per week. So that is going to be our value for mu. And it says to use Poisson's law to calculate the probability that in a given week he will sell some policies, and will he sell 2 or more policies but less than 5 policies. So this variable x here is what represents the number of policies sold. Now, if he sells some policies, that definitely means that he's not selling 0 policies, and you can't sell part of a policy, so we want to have x be greater than or equal to the value of 1. And the probability of that happening is 0.9502. Now, the second part of this problem says, what's the probability in a given week he'll sell 2 or more policies but less than 5 policies? So for this one, we've got 2 boundaries. And notice that for GeoGebra, you cannot change this less than or equal to. When we say at 2 or more policies, we're going to include the 2. But whenever we say less than 5 policies, what we really mean is less than or equal to 4 policies, since our x values are going to be whole numbers. So just press enter, and the probability of that happening is 0.6161.